Hello, everyone. Do you hear me well?
Yeah.
Yeah? Do you see our screens? The guys that are here? Yeah? Okay, good. I'd like to start with, my name is Nata Levitsky, and I'm a delivery manager at Redefining and the CSR responsible here in Moldovan office. And I would like to start our meeting with asking people that are online if they hear me well. Please put a plus. And saying about two rules that we have today. The first rule is please prepare your questions for the Q&A. We will answer them at the Q&A section. This is the first one. And the second one, today, yeah, it's okay. And the second one, I would like very much to ask people that are online to keep their microphones muted. Hopefully, COVID times taught us that the microphones have to be muted. And at the end, you can ask questions. And for the people that are here, I would like to give you a round of applause. Yay! Because, yeah, when I've seen that it was raining, I was thinking that maybe you will be scared and you will not come. But yeah, you did this and you are here. And because you're here, if I can make an announcement, yeah, that at the end we will enjoy some pizza after our presentation, and at the Q&A, I invite you and encourage you to be very attentive and ask interesting questions. Because you will have some prizes, if I can say about this, yeah, right, at the end. Okay, any questions till now from anyone? No. Okay, then your questions can be answered only at the Q&A. Okay, I would like to ask you, who of you before have heard about grid dynamics? Okay, not so many people. Okay, let me ask another question. Who of you are engineers, IT engineers? Okay. Who are willing to make the change and to go to IT field? Okay, great. I think you deserve a round of applause, right? Okay, good. Okay. In this case, let me tell you briefly about grid dynamics, but very briefly because they told me that it's more interesting what you will hear about data engineering from my colleagues. Change the slides. Okay, so Grid Dynamics is the leading provider of technology consulting, agile custom software development, and data analytics for Fortune 1000 and Global 2000 enterprises undergoing digital transformation. We are a big company and we are still growing, and we invite you to grow with us. Still, for now, we are 4,000 engineers in more than in 18 countries. And of course, we have plans to expand our services and our locations. Some of our clients, I think these logos are wide known, so you don't need me to tell you who is working in what. Okay, and I would like to invite you, those of you who haven't heard about Grid Dynamics, those of you who are willing to make a change in their professional career path, or those of you who have friends that are great engineers and would like to join a great company and would like to work with brilliant colleagues, become experts in emerging technologies, and create your own career path to join Grid Dynamics. What we offer skill development because the company grows and we are growing together, some benefit basket, and epic atmosphere. We are organizing different events internally, externally, and yeah, it's a great atmosphere. And my colleagues that are here in this room, they will confirm this. Now I'd like to ask you to take your phones and to scan this QR code in order to follow us on LinkedIn. Yep. Yeah. More courage. Don't be shy. Okay. And to get and to know everything about our career opportunities. Okay. And now I would like to invite Alexei Meglei, who is our big data engineer, to continue our presentation. Thank you.
Hey guys, how is it going? One slideshow. So today we are going to talk about Snowflake. First of all, let's discuss for whom this presentation can be interesting. If your title contains word data in it, data engineer, data analyst, data scientist, data QA, this presentation can be useful for you. Also, it can be useful for backend engineers and for everybody that who want to broaden their technical horizon. So let's start. What are we going to discuss today? First of all, we are going to discuss what is Snowflake, then Snowflake architecture, how to use Snowflake, key features of Snowflake, some case studies, some practice section maybe, pricing in Snowflake, important topic, some limitations, education and certification, and we will have some time for your questions. Yeah, let me introduce myself. My name is Meglei Alexei. I'm senior data engineer. I've been working in Grid Dynamics for 2.5 years. I have 2 years of experience with Snowflake, and I will try my best to tell you about this product. Let's start with the basics. What is Snowflake? If your answer is that's just another data warehouse, that will be true, but only partly. Snowflake positions itself as data cloud or data platform. And the main goal of Snowflake to help you to operate on your data easier. Which problem Snowflake solves? Well, in big data, we have at least 3V problems of big data: volume, variety, and velocity. Volume, we have terabytes and even petabytes of data. Variety, we have data in different formats and with different structure. Velocity, we have necessity to load data fast. And all these problems can be solved by Snowflake. But also, Snowflake provides simple data management, it's cloud agnostic, and it's self-managed. Let's dive into Snowflake architecture. We have 3 layers of Snowflake. There is cloud services layer, query processing layer. In just a second, let me remove this stuff. Yeah, probably need your help. Yeah, thanks. So yeah, we have 3 layers: cloud services layer, query processing layer, and database storage layer. Let's start with the lowest one, database storage layer. Well, Snowflake is data cloud, a data platform. Obviously, we need to store data somewhere. That's the purpose of this database storage layer. Then, of course, yeah, we have some disk, we have some data, but we also need to process this data. We need some compute, RAM, and so on. For this purpose, we have query processing layer, and virtual warehouse is like minimal atomic unit of this query processing layer. And also we have cloud services layer. It's like the most high level layer here. Its responsibilities are authentication and access control, infrastructure management, optimizer, security, and metadata management as well. What is visible right here? Storage and compute costs can be separated. And that's important because we can have different data access patterns. We can have like archive database, which are like petabytes of data, but it's infrequently accessed. Or we can have like small amount of data, but it's hot. It's accessed really like intensive. Both cases can be managed by Snowflake efficiently. Yeah, proceeding, talking about Snowflake architecture, we have different architecture approaches, and Snowflake use hybrid architecture approach. Hybrid, it's a mix of shared disk and shared nothing. So shared disk approach, when we have like a lot of maybe compute units, but we have one centralized data, data storage. Shared nothing, when we have different independent nodes, each which is own data. So here Snowflake Snowflake basically takes the best from both worlds. From shared disk, it took central data repository for persisted data, from sharing nothing, it takes storing some portion of data locally. It helps basically to parallelize things more easier. Okay, let's talk about scaling. So yeah, when I talked about 3V problems of big data, I mentioned volume, and obviously we need to scale somehow, and Snowflake allows us to do it. Basically, there are two main options, scaling up and scaling out. You can think about scaling up options as, like with some simplification, as vertical scaling, and scaling out option as horizontal scaling. So scaling up, you can just increase virtual warehouse size. Please take a look at the image. You can see like X small warehouse size, and you can increase up to 6X large warehouse size. With each step, the performance of virtual warehouse increases twice. But the same is true about credits. So credits, that means how much will you pay for it. If you take a look, for X small, it's 1 credits per hour. And for 6X large, it's 512. So 6X large is much more performant than X small, 512 times. But sometimes even this is not enough. What to do in this case? In this case, we can use scaling out option. So scaling out option, we are using multi-cluster virtual warehouse. Multi-cluster virtual warehouse is, what does it mean? It means that we have multiple clusters in it. And the setup is pretty much intuitive. We can set min clusters, we can set max clusters, and we can set scaling policy. And everything will be done for us by Snowflake. What is important to note here, in order to save money, we may want to choose auto-suspend option, such way that in case if our virtual warehouse is if there is no work for it, it will be inactivated automatically after some period of time. Cool. Let's discuss how to use Snowflake. Well, we have different clients. For example, we have Snowflake UI, a web-based interface, which is intensely used by data scientists, data analysts, or data engineers when they need to investigate on data. I will show you later how does it look, really nicely done. But also we can have, we can use CLI interface, ODBC and JDBC drivers, native connectors for Python, Kafka, and Spark. It's better than connect via JDBC. It's more optimal. It supports some optimizations. And also there are connectors for third-party tools, for example, for Informatica. Okay, here we will have a big section, key features overview of Snowflake. We will not take a look at usual SQL, how to do selects, joins, and group bys. We will try to take a look at some features where Snowflake, I would say, shines. So secure data sharing, data cloning, native support for semi-structured data, time travel, that's my favorite, streams, snowpipe, data masking, UDF, and we'll also take a look at some ML features. Let's start with secure data sharing. So let's imagine the next situation. You need to share some data with your client's team. What can you do? What is the naive approach here? Well, you can say, okay, I have like S3 bucket. I can just export backup, place it in S3 bucket, do it like on a daily basis, and my client team can download this backup and import it. And it will work, but like backups, they are always maybe a little bit, but still outdated. And it looks like we should have better way to do it. And Snowflake actually provides us this way. So you, as a data provider here, will create read-only shares, which will be imported by data consumer. And in this case, there is no additional copying. This is metadata-only operation. Remember the first cloud services layer, metadata management. This is done on this layer, no additional copy and no storage costs. As you can see on the image, there are different data providers, different data consumers, and the relationships between them are many-to-many. Cool. Let's discuss similar topic, data cloning. In this case, let's imagine that you have production database and some table in it, and you want to export this table to stage. For example, you want to debug something or something like that. What is the naive approach here? Well, the naive approach would be something like create table as create table db stage.table name as select star from dbprod table name, and it will work. But let's imagine that your table is 5 petabytes in size. What do you have? Maybe something more optimal here? And the answer is yes, we have. Snowflake proposed to use data cloning feature. In this case, what is called zero copy cloning is applied. What does it mean, zero copy cloning? It means that unless some data is changed, no storage costs applied. So this is also metadata only operation. You are just creating a copy of it, but actually internally no copying is done. But when you change some data, internal div is stored, and you will be billed only for this internal div. So let's imagine if you want to change only 1% of your rows, you will be billed only for this 1%, not for the whole table. And I guess this is cool. Yeah, here is some syntaxes. Yeah, there is chat, but I guess I will answer questions later. There is a special section for it. But yeah, feel free to ask them. Create, like here we can basically copy database schema table. We can copy also like different other objects, and it will work perfectly. Cool. Yeah, let's talk about native support for semi-structured data. First of all, what is semi-structured? That means that the data is nested and has no fixed schema. For example, semi-structured data formats are JSON, Avro, ORC, XML, Parquet. And what is cool about Snowflake, that all these data formats are handled by internal data format variant. So you don't need to have like to remember specific functions for JSON, specific functions for Avro, and so on. Like the access is done uniformly and is like not specific for different data format. It's the feature of variant type itself. Why it is cool? Remember, we talked about one problem of big data variety. This is about it. So we have different data like JSON, Avro, and so on. But what Snowflake actually allows us to handle this data efficiently and uniformly and without any obstacles. So what does it mean? Also, it means that Snowflake perfectly supports both ETL, extract, transform, load, and ELT, extract, load, transform paradigms. So, for example, you can like extract some data, do some transformations, and load it to some neat columns in your data warehouse. Also, you can extract data, load it right away, and let your data analyst or data scientist to decide which fields to use, for example. Let's take a look maybe at some SQL examples. Here, how we can load data into our table. We should specify file format, and that's basically it. Second query is how we can bypass these nested structures. So src, dealership.name from car sales. So we can go as deep as we want by passing this semi-structured data inside variant type. The same thing we can do if we have arrays. So third example, like src customer.name and so on. We can do something more tricky. For example, here, keep like please mention letter of Latin keyword. We can bypass some nested field from table. We can get customer name, customer address, and it's done like in short query. No need to do like to write massive transformations here. We can also not to load data in Snowflake table at all. We can query it right from the stage. So I will show you later how to work with stage, but here you can think about it as just load data from S3 bucket, for example, or from GCS bucket or Azure Blob Storage. Cool. So I guess this is my favorite feature of Snowflake. Let me maybe ask you guys, please, like if you watching us online, please put plus in chat. If you are watching us here, please raise your hand. So how many of you guys used to change some data that you didn't expect to change, like some undesirable updates, deletes? Yeah, I can see it. Okay. So yeah, you can imagine that even for stage database, that can be a big headache. It's nasty thing. But let's imagine for prod database, that can be either big headache or disaster. Like, let's imagine you change some data on prod, and then you figured out that, oh my God, no, what I did, and you are trying to restore this data, and you need to like hopefully you have backups, okay, and you can like restore them. And even in this situation, backups are always outdated, and you will try to figure it out which data was changed by your query, and that's yeah, you can imagine that's undesirable adventure. With Snowflake, it's not a big deal because you have time travel feature. What does it mean? Time travel, that means that you can query data in the past. So let's imagine you have some strange update or strange delete, and you figured out that, oh my God, what I did. After that, you can basically query table as of 1 hour ago, for example, or right before this query, and restore like changed object without any problem. And like there are a lot of other applications, but I guess this is the main one. What is important to understand here, there are storage costs. It's not free, but the same as for data cloning, only diffs are built. So if your table is barely changed, if your data is pretty much static, the total cost will be negligible. And what is also like important, after time travel, if time travel period is over, does it mean that my data is completely lost? The answer is no. In Snowflake, we have fail-safe state. And like during this fail-safe state, the data can be recoverable, but only with help of Snowflake support team. Let's take a look at the examples. So you can query data in the past using specific date time, the first query. You can use offset. For example, the second query, offset is like 3,000 seconds. You can use like statement. So select from my table before, and here is query ID. Most likely it will be queries that cost a lot of problems. And you can even create schema like by cloning some other schema at some moment in the past. So let's imagine you need to debug something and you can't reproduce it, but you know that the bug was like 1 day ago. You can easily copy schema as of 1 day ago and to debug everything successfully. Okay, let's discuss streams. Let's imagine the next situation. We have necessity to run some SQL code on insert, update, or delete statement. How we can do it? Like, what is the naive approach here? The naive approach here would be something, for example, to use triggers like we have in Postgres and in like some other relational databases. It works, but it's not flexible enough and it is not transparent. So it's hard to debug things when you have triggers. What is Snowflake way of doing this thing? Snowflake way of doing this thing is to use streams. What does it mean? Let's imagine we have some table. We are creating streams using this table, and we are capturing all inserts, updates, deletes for this table. And after that, we can either manually or like in automated way using like task and storage procedure, we can load data from stream and propagate the changes maybe to analysis database, for example. Okay, let's discuss SnowPipe. Let's imagine like this is, I guess, the most vanilla, the most vanilla case, how you can like how you may need to use Snowflake. Let's imagine you have some cloud storage like S3 bucket, GCS bucket, blob, Azure blob storage, and you need to load data automatically to your Snowflake table when the new data arrives. The naive approach here. Okay, I can, for example, write some Lambda function, maybe, I don't know, Airflow deck, or maybe even cron job. All this will work, but like it's not as efficient as SnowPipe. SnowPipe supports like native integration with all this cloud storage. So, for example, you can set up integration between S3 bucket and like SnowPipe created SQS queue, and you will automatically get notifications when new data is arrived into your S3 bucket, and you will load it automatically. And this will be done in near real-time manner. If you want to do it in real-time manner, so even with even less latency, you can use SnowPipe streaming API. And remember, we discussed like velocity problem. This can help you to solve this problem. So yeah, let's move on. And let's discuss maybe some compliance and security features. So let's imagine you have strict compliance requirements and you need to hide sensitive data. For example, on the image below, we have like phone numbers and emails. Hopefully you can see my, yeah, you can, cursor. And we need to apply, like we need to hide this data because we have requirements that we shouldn't show this data to everybody who can have access to our Snowflake. What we can do here, like what is our like naive approach? Well, we can either set up strict permissions for this table in the common, even if some of its data is not sensitive, or we can split basically this table and place sensitive data in separate table and like connect using foreign keys the original data with table with sensitive data, and it will work. But let's imagine that you have like select statement and you need to do join in every statement when you need to get this phone number, for example. Or let's imagine you are writing updates, inserts, deletes, and you need to update 2 tables instead of 1. So it's kind of not convenient. What is Snowflake way of doing it? Snowflake provides dynamic data masking. What does it mean? Well, that means that you can apply some policies on these columns, and like the users which have no permissions to view these columns will see something like I don't know how many, 15 nines. So mocked data basically instead of phone number and instead of email. Here is the SQL example. So we are creating masking policy, email mask, and inside we are checking, okay, like what is our current role? If it's analyst, then please return our original value. Otherwise, return mock data. After that, we are like altering table, modifying column, setting masking policy to our column. And we can do pretty much the same for view as well. And that's basically it. Yeah, so of course, Snowflake has a lot of built-in functions, but sometimes it's not enough. We want to use something else. And in this case, we have UDF or user-defined functions. They can be like scalar and tabular, and you can use different programming languages, Python, Java, JavaScript, SQL, or Scala to write them. And here is the example. It's simplified one. So create a replace function, add one, and you can call it just with select. But this is simple example, but actually it can be pretty tricky. So let's imagine you have ML model artifacts, and you can place it right inside UDF function in Snowflake. And instead of like transferring a lot of data from Snowflake to your machine learning service, you will be able to run inference right inside your Snowflake, and to save a lot of money on data transfer and a lot of time as well. And I guess that's cool. Let's continue discussing machine learning topic. So we can do not only like inference of machine learning models wrapped in UDF. We can do even more. So we can experiment in Python notebooks right inside Snowflake UI. After that, we can deploy optimal model with necessary version to model registry right inside Snowflake and use this model for the inference later. Classification like regression, anomaly detection areas are supported. And that's pretty much true for like any task on tabular data. If your task like should do something of classification, regression, anomaly detection stuff, most likely Snowflake possibilities will be sufficient for you. You can take a look at Python module snowflake.ml.modeling, and you will be able to look at the full list of capabilities. But it's important to understand if your area of expertise is recommendation systems. In this case, most likely you will face some limitations because currently we have no support for sparse matrices in Snowflake. But hopefully it will change in the future. Yeah, let's take a look at like Snowflake UI. I don't know, pretty nice, but pretty intuitive at the same time. So different tabs, different results here, history, ability to select databases, like virtual warehouses, roles, and so on. This is classical console. This is new console. Here you have some additional options, like also you can, for example, see dashboards, take a look at your data, maybe buy third-party data sets, take a look at the activity, admin panel, and so on. You can create worksheets in Python or SQL, like share them with other people. So it's beautiful and it's convenient. Let's take a look at some really frequently faced task, optimizing long-running query. How it is usually done? Well, we have some query, we can run explain analyze with it, take the query plan, and after that, we can see what are our bottlenecks and figure it out what to do, how to optimize our query. With Snowflake, we don't have to use explain analyze because for every query plan is saved automatically, which I guess is cool. For example, if you have like one query that is one day that was one day ago, and you want to like reproduce this long-running like this performance issue, but you don't have this possibility because the data is changed. With Snowflake, it's not a problem because you can use you can see the query plan of the old queries, and what you can see here, you can see how many time do you spend on each phase, aggregate, join, table scan. And also, apart from it, you can use this graphical representation in debugging purposes. For example, you have, let's say, 50K rows here, 50K rows here, and after join, you have like 30K rows. That means that some rows are removed. And this is useful for debugging. Okay, let's take a look at more complex example. What else we can see here? We can see not only nodes by execution time, like here. We can also see some statistics like processing, remote disk I/O, synchronization, initialization, how many bytes scanned, how many partitions scanned, how many partitions pruned, how many bytes like taken from cache, and so on. Yeah, let's examine this use case because it's the most common one. For example, we need to load Parquet files from S3 bucket to Snowflake using SnowPipe. Yeah, it doesn't matter actually if it is S3 bucket, GCS storage, or Azure Blob storage, because the principle is pretty much the same. So let's take a look how it is done in details. So first of all, we need to create an external S3 stage. What does it mean? What does it mean S3 stage, external S3 stage? That means that you are telling Snowflake that please register this URL with these credentials or other authentication mechanism as stage name alias, such way that I can use stage name after it, and I will be able to access this URL. Here I'm passing credentials, which can be okay for like one-off jobs, but usually it's better to set up storage integration. It's a little bit more complex, but like it's a much more mature way of authentication. Well, we created external stage. We need to create pipe here. We are creating pipe with auto ingest option equal to true. And here we are specifying command like copy into schema name.table name from. And here, please mention at symbol. This is our external stage created on the first step. Cool, we created pipe. What else? Then we need to set up integration between Snowflake and our cloud. So here we need to set up SQS. So SQS is AWS Service Simple Queuing Service. We need to set up SQS notifications such way that when we have some new data in our S3 bucket, we will have notification to this SQS queue. And SnowPipe can understand that, okay, we have some new data, let's run this copy into code. So we are getting the value from notification channel column and passing it to SQS queue ARN. Then we are uploading data file to the S3 bucket, waiting for 10-15 seconds, and we can verify that the data was loaded. Cool. Let's discuss pricing because it's an important topic to understand. First of all, there are 3 editions. Like standard is the most, like the cheapest one, and business is the most expensive one, and enterprise is in between. So standard, it's not so restricted as you can think. Most likely it will be enough for you. But if it's not, for some reason, you can use enterprise, which includes standard plus materialized views. So let's imagine you want to optimize select from your views such way that the data is automatically pre-cached. Multi-cluster warehouses, remember scaling out options, we discussed it. Increased time travel, it can be up to 19 days in Enterprise Edition. Dynamic data masking, also part of Enterprise, we discussed it, and external data tokenization, like additional security option. And for business, it's pretty much the same as for Enterprise, but also there are some additional compliance options and additional security options. Yeah, what is also important, like the payment can be on demand or Snowflake can be pre-purchased. Yeah, I guess it's quite intuitive. On demand is more flexible, but more pricey. Pre-purchased is less flexible, but less expensive as well. Main costs in Snowflake are like compute costs, storage costs, and what is important here, data transfer costs. What does it mean, data transfer cost? That means that you are getting billed for different region or different cloud transfer costs. So why it is important? If you have, for example, your main workloads running on GCP, then probably it makes sense to build Snowflake on top of GCP cloud. You will have an option during like creation of, during initial setup. Because in this case, even if you have different region, the data transfer cost will be much less. Yeah, limitation of Snowflake, main of them. Snowflake is internet dependent. It's built on top of AWS, Azure, or GCP. So it's by design less configurable than theoretically, at least, you can build using AWS, Azure, or GCP features. But like in practice, it's flexible enough, and that should be fine. And it has poor support of unstructured binary data as of March 2024. And let's imagine that you are excited and want to know more about it, what you can do next. Well, first of all, please take a look at Snowflake documentation. It's marvelous. I highly recommend you to take a look. Also, there are some free credits available, so you can, for example, to experiment to set up Snowflake for free and to play a little bit by yourself. Or you can use Snowflake training lessons. They are also available. Yeah, you can have Snowflake certification. There are like 2 of them, core and advanced. So yeah, I guess that's it. Do you have any questions?
Thank you, Alexei. Thank you very much. We have some questions in the chat, so you can decide we'll start from the chat or from the hall.
Let's start from the hall.
Okay.
Yeah.
I have a question regarding performance profiling. We're showing this user interface, how you like investigate the performance of specific queries. And I was wondering how would that combine with UTFs? For example, like write Python functions, will that be elaborated in the like user interface, the scheme? How deep it can actually go into the function themselves? For example, if I have like slow Python code for something.
Yeah, like good question. So this UDF functions will
Can you please repeat the question in short version?
Yeah, thanks. So the question was, okay, we can have this profiling, nice looking profiling page, But let's imagine I have UDF function. So can we actually profile this UDF function? Can we like understand that the problem is in this UDF function? And the answer is like UDF function works as black box for Snowflake, but you will be able to see this this execution time in processing itself. So you will be able to understand that something is wrong with processing, and then like you can eliminate like simplify and eliminate different things and figure it out that okay, without this UDF it works like 10 times faster, and yeah, something like that. Yeah. Go ahead.
The topic of the Python functions and the Python environment, I was just wondering what kind of, if there are any limitations on the libraries, how would you install or support? But because, for example, when you create a new environment, you have to people install everything or don't install the environment, and sometimes it's just like it's a pain.
Mm-hmm.
I wouldn't say where exactly that pain is, but it's a pain. So how does it, does it support all the libraries available? I can install anything?
Yeah, the answer is, the question first of all is what we can do with dependency management, so in UDF, because we can have a lot of libraries inside Python itself, and how we can set up this environment. Actually now it's in preview feature, I guess, but we can use Docker containers even for UDFs. So in this case, you can have everything set up for you. Yeah, we had an example, for example, but you understand me. When we have like ML model artifacts, they're basically like jar archives, basically. And we use them because they are packed, and it was enough for these purposes. So it's pretty flexible, I guess the answer is.
Sounds like more pain.
Yeah, there's more pain, but it's more advanced solution.
Yes.
It's okay. I guess let's start with, what about begin rollback? Yeah, of course, when you are experimenting in UI, like it's a rule to run begin at the beginning, and if something is wrong, you can write rollback. But let's imagine you committed some code, and this is being run, this malformed query by like from the server itself. There is no begin rollback feature here, and in this case, begin rollback won't help you. But yeah, usually, of course, begin rollback is extremely useful.
Okay, we skipped some questions in the beginning, I think,
Mhm.
and we have some above.
Mhm.
Will you read or should I?
Yeah, let me maybe skim this chat. So pip install modules, we saw it. Main challenges or missing functions in Snowflake at the moment. Yeah, I guess I mentioned limitations, so partly answered it. Is there an account for Grid Dynamics employers so we can train on Snowflake? You can create your own one, and you will have free credits. It's available. Can Snowflake ML use any algorithm or only predefined? For example, can it use NLP? So about NLP, mostly Snowflake supports like algorithms based on tabular data. So not sure about NLP. You can take a look at Snowflake ML forgot something, and you will be able to see the full list of capabilities. But usually it's only for tabular data because, well, we have tabular data in Snowflake. So yeah. Postgres supports JSON-B data type, a binary variant of JSON optimized for easier access. Are binary data formats such as JSON-B supported by Snowflake? Yeah, like we have semi-structured data like JSON, Avro, Org, Parquet, and XML. They all are fitted for variant data type. So we don't need to have JSON-B data type. We can use variant, and it will work. It will work fast. I have no like comparison with Postgres, but it should work fast. Yeah, cool. I guess.
And before pluses, it was another questions. So
Oh, yeah, sorry. Can Snowflake help with data science? Yeah, yes, we can. It can. Can we apply ML model to data using Snowflake? Yes. For example, inside Python UDF. Yeah, all questions are valid. So the answer is yes. Can Snowflake make HTTP requests? For example, for each row, I need to make post request. For example, inside UDF again. To be honest, I'm not sure. Like I never tried it. I don't know. Need to check in documentation. Yeah, but I don't know if it has like internet access. Yeah, maybe like because maybe inside UDF we are not like it's like separate container without in isolation. Can Snowflake make HTTP requests? Yeah, answer. How to optimize Snowflake queries? Can we make index on table? Can we make hints or C query plan? Yeah, query plan I answered. Can we make index on tables? Yeah, we can like set up partitioning. It's not like, there is no something like B-tree indexes like in usual database, but we can use partitions and to set up partition key such way that some partitions will be pruned. How to optimize Snowflake queries using our beautiful UI interface with graphical representation. Hi, Alexei, thanks for your demo. You're welcome. Please advise on the following. Do you know what is the real DB it's based on? Yeah, it's private information because there is no open source thing, but Snowflake mentions that it used data formats similar to Parquet. So yeah, actually not so much information that I know about it, and I guess it's hidden. Is the support any good? Yeah, it's like I remember cases when something went wrong. For example, like some data is lost and it was necessary to restore them using this fail-safe state feature. And yeah, support helps and helped like in short period of time. How you monitor the performance is the automatic scaling. Monitor the performance, automatic scaling, I guess. I guess that means about scaling out option, about multi-cluster virtual warehouse. You can monitor it in the panel itself. Do we have? Yeah, we have actually a little bit of time. What are limitations of Snowflake? For example, comparing to Spark. Look like we all need to migrate from Spark to Snowflake. It's like you can use Spark and Snowflake in combination because it has different like reason to use them. But yeah, usually like Snowflake has native Python connector and they are integrated like neatly. For example, with native Python Spark connector, you can have even predicate push down. So everything is pretty optimal. You don't read a lot of data. And yeah, you can give it a try and try to use on free account using Snowflake, like set up Spark server, Snowflake, and try to use them combined. Yeah.
So my question is about how Snowflake stores data internally and about query optimization. So for example, I have a table where I store data time as unique epoch, Unix epoch. So it's integers. When I try to query data and filter by this column using another integers, it works slow. But if I convert this count to data time using the 2 timestamp and the Z, for example, and then compare this count with date,
Mhm.
It works much faster. So why it happens?
Mhm. So yeah, I need to explore, need to like investigate, see the query plan. But like usually, if you have, do you have like it's partitioned column?
Table is partitioned by this count, and so like logical way is that when we use these integers as is without data transformation, it should be faster, but actually it works slow. It's what we saw on production.
Yeah, that's strange. Like, yeah, of course you can like partition by this column, but
Can I say something? So my, how to say, assumption is that it counts by the years and dates. I mean, it looks like to the date format, and it's like faster because it compares the date like the month, the date. But when it compares like this huge, or not so huge integers, it's like doing some other mathematical computations which takes long. That's my assumption.
So it understands that the integer column actually stores data times.
I think it like sees it like not a timestamp but an integer. Yeah, and it's doing some mathematical computations. But when it's in the time format or date format, it does some like date comparison, and it might be faster.
So the faster so it is faster when we convert integer count to date and then compares date. So Snowflake perform date comparison faster than integer.
That's the yes. This will be, but you can check if it's maybe open. It's not open source, right?
it's not open source. Yeah.
Okay.
Yeah.
Just reading the document.
Yep.
Again, regarding the underlying storage of Snowflake, how can I control the security of the data they store on their side? For example, my clients want to be sure their data is encrypted with a specific key or something like that. How can they assure? Are they like GDPR compliant or something like that?
Yeah, they have different options, like security options. For example, there is like external data tokenization that I didn't mention in my presentation, but that basically means that all data like that you want to be like encrypted, that goes in and out Snowflake, like we have some encryption applied to it. For example,
in transit, yes.
In transit,
But
yes.
at rest.
At rest, I guess it's by default encrypted in rest. Yeah.
Can I control that encryption? Where is that data stored?
The mechanism. Yeah, it's I don't know if you can like choose encryption mechanism. Most likely it's good enough. But yeah, I need to like look at the documentation because I don't remember now. Yeah.
So for the time travel, how granular it is? I mean, can you go like every second back or like millis?
Every change. So
every change.
yes.
And if it's like a real-time application which has a lot of changes,
yeah, in this case, it's gonna be costly. For example, if you have
changes like
yeah.
thousands.
Yeah, maybe it worth it if this data is like precious, but usually like it's not designed to be applied to data that is changed yeah, really frequently. So yeah. Yeah.
I actually have a few questions and kind of different topics. First is about the continuous deployment, continuous integration part. You know, it's usually everyone knows that it's a problem to deliver some new like changes in the schema, especially or data. And I was wondering if there are any innovations in that area in Snowflake.
Yeah.
Do they like give any tools for deployment?
As far as I know, for now, there is no such tools. So you can use like third-party tools, maybe to handle migrations by yourself. But yeah, I guess that's it for now. Maybe they will figure it out something. I don't know.
Right. So the same question in the same direction about you were showing us the user interface to the web, as understood. This is kind of like an application.
Yes.
Where you just deploy it somewhere in the cloud. What about the CLI tools?
CLI, CLI interface, I didn't place it because it's not so like interactive.
Yeah, it's just a blinking push.
Yeah. So, but yeah, it's quite advanced. So you can do a lot of stuff even from CLI, and you can do even some stuff that you can do via web interface. For example, I guess load some files to stage. You can do via CLI, but not in web interface. So yeah.
So another question is regarding the data versioning. For example, if I want to do some A/B testing, I don't know, experiments with the data, and my question is, for example, you were talking about the time travel. Does it have any downtime?
You can use timestamp, yeah, and to address some state of your data in the past.
No. I mean, like, for example, if you would like to downtime.
Yeah, downtime. I see. Downtime, it's usually done pretty fast. Like, sorry, what do you mean by downtime in time travel?
For example, if I change something and I need to roll it back.
Okay.
So the downtime, like database will say like halting.
No.
Response.
There is no logs, definitely. That's like a usual query, but like the query that is restoring some data. So it basically like insert, select from, add some timestamp.
So that you are running this time travel and something happens, like new data is pushed to the database. Will this new data be in the time? Well, how it happens? I mean, to this data that comes in your time travel, what happens to the data?
Yeah, usually like when you like specifying time travel, you are specifying some timestamp, and this is like finite set of data.
Is dropped, right? Like the new data, which is
you can yeah, that's yeah, this time travel probably I would have placed this example, but it is usually done like you have ability to access data in the past. This is on you, how you will restore everything, but at least you have access to this data that was deleted or changed. So that's the main idea, but Snowflake, it doesn't know how to restore data because it depends on business logic. And it just provide you a tool to access deleted data. And there should be like some data specific query from you. Yeah, I guess.
Here, yeah, I need to stop you. And if you have any questions in the hall, you can discuss it there. And thank you very much, Alexei, for this speech. It was very insightful. I know for sure. And now I want to ask you to stop the screen sharing. And we'll have around 4 or 5 minutes break. If you need to in the office, if you need to have some drinks or to go to the restroom, you have this time. And online, you also have this time. And I'll ask our second speaker to connect and to share his screen.
Yeah, thank you, guys. Hello, everyone. It's my pleasure to welcome you on Redefining. And today we'll navigate the landscape of Pandas, Dask, and PySpark. For any of you who don't know me, I'm Mihai Coslet. I am data engineer here at Redefining with 2 years of experience, and in data engineer I have 3 years of experience. So what we'll have today. For today, we have different tools. First of all, we'll see something from Pandas, Dask, PySpark, and we'll see some benchmark testing for reading, filtering, and joins. But first of all, why do we have so many tools? Can't we just learn one of them? Why do we need PySpark? Why do we need Pandas, Dask, Flink, Pig? Can we just learn one of them? And the answer is unfortunately no. I know it's hard for you to know a bunch of tools. I know it's hard to switch from one to another, but the answer is still no. And this is because of diversity of data processing tools like Apache Spark, Pandas, Dask, and others stem from varying needs and scenarios in data processing. And each of these tools has been developed with specific goals, strengths, and use cases in mind. So let's find what are the strengths and use cases. I will start with Pandas, but firstly, please raise your hands if you already have experience with Pandas. And in chat, you can please just. Okay, no many of you, and this is unexpected. Seriously, I thought it will be forest of hands, but okay, more interesting for me. So, Pandas, it's a widely used Python library for data manipulation, and honestly, it's really very popular. And why it's so popular? Because it has some very important and strength keynotes. First of all is efficient data handling. So Pandas provide powerful tools for data manipulation, allowing for easy handling of large data set and complex data transformation. Another keynote is time series. So with Pandas, we can easily search and do some manipulation with time series. This includes built-in function for time series data analysis, making it ideal for financial, economic, and environmental data. Also, Pandas have a lot of source. You can read from a lot of source like CSV, Excel, SQL, JSON, Parquet, and really a lot of them. And you can also write. So we have a lot of things like CSV, Parquet. Let me not repeat myself. We have integrate data cleaning. So it provides extensive function for detecting, cleaning, and filling missing data. So if we have some missing value, we have fill, be fill, we have replace. And if you don't want this data, you can drop them. So this facilitates the preparation of raw data for analysis. Performance improvements in Pandas 2.0, we have introduced significant performance achievement. So now we can use PyArrow data type and PyArrow engine for increasing our speed and decrease our memory. So this is really good. And simplified data visualization. So with Pandas, you can use CRBoard or Matplotlib, and you can do it easily. Export your data analysis via function plot, or if you want, you can use describe or info. So this is really cool when you want to understand your data. Next, let's go to understand how does Pandas work. So at the heart of Pandas, we have two primary data structures. First off is data frame. It's a two-dimensional size mutable, potentially heterogeneous tabular data structure with labeled axes, rows, and columns, as it's shown in image. And it is essentially a collection of series objects that share the same index. And the second, it is series, a one-dimensional array-like object containing an array of data. So it can be an NumPy array and an associated array of data labels called index. Now let's go to what Pandas is good and in what Pandas is not so good. So firstly, it's easy of use. Like I said, Pandas is very popular. You can find it in many data analyst and even data engineering fields, because it have a very user-friendly API. First of all, second, it have very good documentation. Alex suggests you Snowflake documentation. I suggest you Pandas documentation. It's really very good. And the last but not the least, Panda have a very good and very big community. So Stack Overflow is still live. I know we have ChatGPT and it's good, but still Pandas have a lot and really a big community in Stack Overflow. Contra, And this is where Pandas is not so good. First of all, it is memory limitation. And this is one of most drawbacks of Pandas. So Pandas store in memory your dataset. And this is it's good because it provides us very speed. So we can easily increase our speed and do some manipulation of data very quickly. But if this dataset is too much and cannot fit in your memory, you will have to switch your tools. And the second, it's limited parallelism. While Pandas does offer some support parallelism, it might not fully leverage other available CPU cores for complex operation. So let's imagine that we have a dataset that could not fit in Pandas, but we still want to work with Pandas. What we can do in this particular case? And here that is Dask appears. So Dask promotes itself as Pandas with a new engine, but it's not so a good promotion because Pandas is not just because Dask is not just Pandas. So I again ask you to raise your hands if you had some experience with Dask. Okay. Okay. This was expected, but still it's shocked me because only 2 humans. Yeah, Dask is not so popular, but still it's powerful. And the most important, if you know Pandas, I congratulate you, you know Dask, let's say, because it really has a familiar Python API. So not just Pandas, but a lot of them. Dask is an open source library designed to provide parallels to the existing Python stack. So it's, like I said, not Pandas. It could be NumPy, it could be sklearn, so it's really cool. Some of keynotes, like a talk for 3 minutes, it has a familiar Python API, and I will show you when I will do some benchmarking. Second, it scales out to cluster, so we can scale our code 1,000 nodes cluster in-house, in the cloud or HPC, with no need for code rewrites. But it also can scale down to a single computer. So if you want to do some testing or you don't want to go to cloud, you can use your code for 100 gigabyte dataset in a laptop or 1 terabyte dataset on a workstation. It supports complex application, so it enables advanced algorithms for statistical or machine learning, time series or local operation. Provide real-time visibility. So I think many of you know Spark. I hope so. So you know that Spark have own UI. So Dask UI is like the same. You can see for bottlenecks, you can see for how the executor is doing. And it's really cool for debugging. And the last, it's support GPU acceleration. So if you have CUDA, my congratulations, firstly. And the second, you can use your GPU, so your code will be even faster. Okay, but how does Dask work? And it's quite interesting. It have nearly similar architecture to Spark. So Dask is composed of 2 parts. First one is a collection of API for parallel list, array, data frame, for natively scaling NumPy, Pandas, and sklearn. For this, we have high-level APIs like Dask array, what parallelize NumPy, Dask DAG, what parallelize list, Dask data frame, what parallelize Pandas, and Dask ML, what parallelize sklearn. We also have low-level APIs. This is Dask delay, so it's lazy parallel objects, and Dask Dask feature, sorry. It's eager parallel object. And the second, it is a task scheduler for building task graphs and coordinate scheduling and monitoring task optimized for interactive workloads across CPU cores and machines. Okay, so let's go to the pro and contra. For the Dask, we have scalability. So Dask data frame can handle a large when available memory by breaking them in a smaller partition, what can process in parallel. It has parallel and distributed computing, so Dask inherently supports parallelism, allowing operation to be executed on multiple CPI cores. And the second, my favorite, it's lazy evaluation. So if you know, again, if you know Spark, you know what it is. until you don't compute in Dask. This is not an action, but it's just a method named compute. Your data frame or any collection in Dask will be lazed. So this encourages us to free some memory until we'll have new parallelized data. Okay, but let's see what we'll do if we have petabytes of data. What we can do in this case. So if petabytes of data, Dask is not working. And if you have 1 gigabyte of the data, Pandas, Dask is also not working. Why? Because of volume. Dask can be useful only if large datasets are used and if operation will have performed is a Dask function. And complexity, because we have new features like parallel, like distribution. So the learning curve is medium. It's not so hard. You can easily find the documentation. It's as good as Pandas, I will say. But still, it will add some difficulties for you. And let's go to big guns. And this is Apache Spark. Apache Spark, again, please raise your hands. Okay, still more. Apache Spark, raise hands, please. Okay, still not expected for me. So Apache Spark is an extremely fast and general purpose cluster computing system. And what have Pandas and Dask didn't have streaming data. So Apache Spark does, and this is really cool. So unified processing of data in batch in real time, streaming using your preferred language. So Apache Spark can work on Python, SQL, Scala, Java, or R. It's mainly used in Scala due to dataset, but if you don't need dataset, you can use Python, PySpark, SQL, or Spark in R if you need just data frame and RDD. Another cool feature, it is SQL analytics. So it's execute fast, distribute NFC SQL queries for dashboard and ad hoc reporting. And it's run faster than most data warehouse. Also, data science at scale perform EDA or exploratory data analysis at petabyte scale without having to resort to downsampling. Apache Spark is used in machine learning with libml-lib. So you can train machine learning algorithm on a laptop and use the same code scale to a fault-tolerant cluster of thousands of machines. Again, Spark is lazy. So we have transformation that are lazy. All the transformation, it is what you get from, let's say, an RDD, not RDD, sorry, but data frame. And you do some modification, you still have data frame. And action, if you from data frame transform to a list or to another data structure. And fault tolerant. So Apache Spark is designed to handle worker node failures. It achieves the failure tolerance by using DAG and RDD. So it's resilient distributed dataset. DAG contains a step-by-step how this transformation is done, how this pipeline is working. And if something is not doing good, you can rerun. So Spark will rerun this DAG for you. I see some questions, but I will answer them at QA. How does Apache Spark work? So the Apache Spark frameworks use a master-slave architecture that consists of driver, which runs on a master node, and many executors that run across worker nodes in the cluster. So in the image, you see the master-slave. We have driver program. What is the Spark driver? The driver is the program or process responsible for coordinating the execution of a Spark application. It runs the main function and creates the Spark context, which connects to the cluster manager. So we can see our Spark Connect. Spark context is the entry point for any Spark functionality. It represents the connection to a Spark cluster and can be used to create RDD, accumulators, broadcast variables, and many of them. For worker node, the worker node has executor. So executors are worker process responsible for executing tasks in Scala, in Spark application. They are large on worker nodes and communicate with a driver and cluster manager. Executor run tasks concurrently and store data in memory or disk for caching and intermediate storage. In executors, we have task. So task is the smallest unit of work in Spark, representing a unit of computation that can be performed on a single partition of data. Let's see what we have for Spark. So for Spark, we have speed and performance. So Spark is really very fast. Only if we are using enough size data set. The second, like I said, we have many language support for Spark and our APIs. It uses advanced analytic capabilities. And last, we have Spark UI, where you can see how your pipeline is doing. If you will see some bottlenecks, maybe data skewness. For contra, we have memory management and resource utilization. So Spark relies heavily on memory for its performance, but also consumes a lot of memory and CPU resource, which can lead to memory errors, garbage collection use, and resource collection. So this is basically OM issue. Spark is the most hard to learn, so it has hard learning curve because it has a lot of modules, it has a lot of internal working, and it's really one of the most powerful, but still one of the most hard tools to use and to learn. And the last, it's small files problem. So Apache Spark faced difficulty when dealing with large number of small files. More files within a workload mean more metadata to parse and more tasks to schedule, which can significantly slow down your process. And let's go to data skewness. And I will start Dask. Why? Because with release 2020.0.2.1, Dask data frame introduced a new shuffling method called peer-to-peer. It's on your right. So this new shuffling, it's making sort, merge, and join faster and use constant memory. The system is designed with three aspects mirroring the problem list above. So first one is peer-to-peer communication. Reduce the environment where scheduler shuffling becomes on ON. Operate from the scheduler perspective, removing a key bottleneck. So here in the image, we have task-based shuffling. So this is how it is in our tools. We have inputs. If we need to shuffle, we need to have some intermediates where our data will be collected, and outputs. And on your right, we have how it is implemented in Dask. You have the same inputs, but now we don't have intermediates. We have the barrier. And this barrier, it gives us ON. Second, it is disk by default. So stored data accessorized on disk eventually. Dask can now shuffle dataset on arbitrary size in small memory, reducing the need to fiddle with right size clustering. And the last is buffer network and disk memory. Avoid many small writes by buffering sensitive hardware within in-memory stores. So shuffling involves CPU, network, and disk. Each of them brings its own bottlenecks when dealing with many small pieces of data. Let's go to the Panda. So Pandas, being primarily a single machine library, doesn't have built-in mechanisms specially designed to handle data skewness across a distributed system like Dask or PySpark. However, it's still a powerful tool. So if you have a small data set, please use Pandas. It's very good. And the last, it is PySpark. So in the image, if someone doesn't know what data skewness looks, so you can see the blue when each core have the same workload, load, and with red when some cores do more work than others. So PySpark offers several mechanisms to deal with data skewness, particularly its distributed processing capabilities. Techniques such as salting and custom partitioning are commonly used to redistribute data more evenly across the cluster. So salting involves setting a random prefix to k values to break up large partition into smaller, more manageable ones. And custom partitioning allows for a manual specification of how data shall be distributed across nodes. And let's imagine what we did our pipeline. Now we want to deploy. And how we can deploy it? Let's start with Pandas. So Pandas, unfortunately, cannot be directly scaled across a cluster because it was designed for in-memory data analysis or a single machine. But in local, you can deploying Pandas straightforward at its run on single machine. Let's go to the Dask. So with Dask, you can quickly scale out to many machines for just a few minutes. And in local, you can run without any setup. Not really. You have to still PySpark on the Dask, but after this, you can run it. So Dask work very well, scaling ranging from a single machine to a cluster of many machines. And the last is PySpark. So like I said, PySpark, it's inherently designed to scale across cluster. And still, if you can burn for testing purpose, or if you have small data set, you can use it locally. So now let's play a game. A game, it's very easy. So on your right, you will see the tools. On your left, you will see the size of database. Your job is to match the right tools for this dataset. So please, in online, just write your answer in chat. Offline, if you want, you can raise your hand. Okay, go. Yeah, so here it's just Pandas. And if you listen carefully, you already understand why not Dask and PySpark, but let me say it again. Why not Dask? Dask is working very well if you have a large data set because of partitioning and basically it's the same like PySpark. PySpark is trying to split the data into blocks, what have 32 megabytes, if I'm not mistaken, or 64. I need to recheck the documentation. And if the data set will be small, it will split in much less workers, and it will have more work to do. Okay, let's go to another 1 gigabyte to 100 gigabyte. Okay, Dask. Yeah, so actually all of them. Yeah, so basically, if the data feels in the range of 1 to 100, there are 3 options. We can use Pandas with parameter chunk size to load the file into Pandas data frame. We can use this data set and import them to Dask data frame, or we can ingest them to PySpark data frame. Yeah.
So for the memory, 100 gigabytes should be the RAM of the system or something like that?
We can use chunk size, so it will take step by step. It will split.
So you can increase the swap size, so put everything on the disk.
Okay, and the last, let's say we have more than 100 gigabyte, what we'll use?
Not Pandas.
Pandas, it's a very good choice.
Not Pandas.
Oh. Okay.
You can sample the data.
You will have a lot of work to do. So the right answer here is PySpark. Pandas, it's out immediately due to the local memory constraints. How about Dask? Dask might be able to load the data into Dask data frame, but it still depends on what data you're using. And PySpark can handle petabyte of data, so you're free to use. So congratulations, you did very well. And now let's go to benchmarking test. Firstly, here's the code to the repository. So if you want to test on yourself, you're free to use. Don't be afraid of the code structure and the code smell, and the Python, and anything else. But still, it's good. So can we move? Okay. Technical setup for benchmarking. Here's the version of libraries I used. Here's the CPU and RAM. So I use 2 cores, and RAM I use 10 gigabytes. For this, I create a Docker file. So I restrictionate how much resource can my container use, and specs just for you to understand. Another warning, PySpark is operating in a local mode, hence it's not utilizing its full capabilities. So take in mind when you see PySpark, it's not the full capabilities, but still it's very good. Let's see some code. So first is reading CSV pandas. Here I want to highlight Pandas could not read multiple files from once, so I had to do this for loops. And the second, I want to highlight to annotation timing decorator. So for your understanding, because it will be very frequent use, this is a decorator what's make 100 execution of the same function and store the time for each execution. Now, after this, it's outputting me the average. So here, then we'll see benchmarking will have average of 100 execution. Dask, like I said, Dask have familiar Python API, so it's not so difficult to read, but still have one improvement. We can read all multiple CSV with star CSV. PySpark here, I want to highlight again, it uses local. So reading CSV with shape, we have 2.6 millions. And time take. So Pandas default, it took me 4.95 seconds and nearly 1 GB memory. If I use dtype and engine PyArrow, it decreased to 1.52 and memory decreased nearly to half. So it's very cool. Dask. Dask, like I said, it's lazy. So if you didn't make compute, it will not give us the right answer, but I still put. So if we did not use compute, it's 0.014, and if we use compute, it's 5.22. Memory usage only on compute here, so it's nearly to Pandas PyArrow. But like I said, Dask, it's the same Pandas with engine of Dask, so we can use here PyArrow too. If we use PyArrow, again, if it is not compute, we'll have 0.015, so it's okay. And if we compute, we have 2.13. Memory decrease, but still, it's okay. PySpark. I don't think it will be shock you, but if you use infer schema, it will take more memory and more time with define schema. So yeah, I didn't open something new for you, but still, PySpark is also lazy. So here we have 0.20 if we didn't make any action, and 0.27 if we use some action. For action, I use just data frame count. Memory usage. For just without action is 200. With memory is nearly 400. And with defined schema, it read in 0.29 and take memory 300. Let's go to the JSON. So let's go to the benchmarking. Here we have Pandas default. And I don't quite understand why, but with JSON, it took less memory. So I need to recheck and understand why. But it took 1.41 for Pandas and 37 megabytes. For PyArrow, it took 0.29 and 18. For Dask default, it took 1.57, and with Arrow, it took 1.72. If infer schema, it took 0.43. If define schema, it took 0.08. And Parquet. So for Parquet, we also can use PyArrow and Auto Engine. Dask the same, and PySpark. Okay, quite interesting. For Pandas, if we use Parquet, it took 0.05 and memory 37 megabytes. For PyArrow, it took 0.08, but megabytes took only 18. Dask, it took 0.06 and 19 gigabytes. PyArrow, it took 0.08 and 19 gigabytes. PySpark, it took 0.10, 16 gigabytes, and PySpark 0.07, 16 gigabytes. So here I want to highlight, don't think PyArrow is your ultimate weapon. It's really cool, but you still need to understand. If you will read the advice for Spark optimization, one of the advice will be use Parquet. Here in my benchmarking, I show you what Parquet was the most fastest and the most easiest in memory usage. So if you have a lot of data and you want to query this data, one good approach is to transfer from your data to Parquet data or to another data store schema. Filtering. For filtering, I have easy filtering operation and heavy filtering operation. For easy, just took the month was January, and for heavy, I filtering using filtering. Okay, I took unique array and array delay. After this, I group by unique array and mean by array delay. Here's the same for PySpark, and here's the same for Pandas. So nothing new for you. Let's take the easiest. So default, it was 0.03. If I use PyArrow, it's increased to 0.17. If I use Dask, it's go to 4.78. If I use PyArrow, it's going to 1.7. And PySpark, it took 2.16. And if you define schema, 1.19. And now the most interesting for heavy. For heavy, Pandas default took me 0.21. For PyArrow took me 0.14. Dask took 4.37. PyArrow 1.72. For PySpark inference schema, I got error, and this error is due to the average array delay. So inference schema didn't see array delay as a numeric type, so it could not get average. And once again, if you know the schema, please use the schema because it gives a faster query and less memory. And the joining, for the joining, I don't took the full dataset. I only use 15%, and I create one static dataset. So joining, for Pandas, we have just default join, that is using with merge, and it took the best engine. For Dask, we have the same default, but Dask have also broadcast. So use broadcast if your second dataset or one of your dataset is small enough to fit in your memory. And with PySpark, it's the same. So Pandas, here you see the shape. My first dataset, like I said, I took 15% of them, and the second synthetic is just 20,000. For Pandas, it take me 29.61. Dask was better, 20 and 29. If I use broadcast, it was even better, 14 and 36. And now for PySpark. So PySpark, it took me 2.61 and 1.31. So this is the result what I get. Now, if you have some question, you are free to ask them. Okay, go ahead.
Started your career of data engineering here in
No, I started in another company.
in another company. Okay, then that applies to both companies. Your clients, how many of them use Snowflake? How many of them use Spark and Dask in production?
Okay, so let's take the question was, in my experience, how many clients use Snowflake, how many clients use Dask, and how many use Spark. So I start with Dask, no one. Like I said, Dask is promoting like the same Pandas, but with the different engine. If you look at their tutorial in PyData on YouTube, you will see they're promoting itself like the same Pandas, but with a Dask engine. That's not the true. Pandas is more powerful, but still Pandas is the newest. So it's the earliest tool, and it have great competition with Polars and another tools. Like same, we have one library for parallelizing the pandas. I forget the
There's
name.
also bias if I
Yeah.
open it.
Snowflake. Unfortunately, Alex, I'm covering myself.
Currently, as far as I understand, Snowflake takes about 20% of all data warehouse. So every
That's the ratio, but in numbers, how many, like 5, 10 clients?
oh, from my experience,
Yes,
like 2 or 3.
2, 3 clients. And how many of them, of all the clients, use Spark in production, not for R&D?
Okay, so actually, at my all project, I had 3 projects PySpark and 1 project with Pandas. So not PySpark, sorry, Spark. One of them was PySpark, but 2 of them was
Still the same.
yeah, not really, because Spark on Scala is different from PySpark.
In the engine, the
Oh,
framework is
yeah, it's quite still some, but when yearless updates you get on Spark on Scala, the Spark was firstly created for Scala, and we have because compile time we have a dataset it's more optimized. So this is in my experience. The second,
Spark and Snowflake, they are like same number of clients.
from our experience, yes.
Thank you.
Was wondering regarding the Dask tool. I have used it, but never made any real clusters. And I was wondering, how does it handle the data transfer? So for example, I have a machine, I have this machine somewhere in the cloud.
Okay, so Dask have a package named cluster. In the cluster, you can use local cluster, a lot of HP, a lot of cloud. So firstly, what you have to do, you have to create a cluster and create a connection to your data storage. After this, you will get the same, like when you use read.json, you will, or let's say read parquet, you can use your S3 URI and will transfer your data to your local.
So does it automatically?
Yes, if you use a client, so cluster, and you can create different clusters. Any more questions?
As I understand that the DAG and the Spark, they are both lazy. They do have this pre-processing check if everything goes fine, something like that. I know it does exist in the Dask.
I not say pre-processing because
No, I'm saying if you run the query, they might run some dummy data through the DAG.
okay, so if you will do something, so as the question was, if I'm using laziest, does Dask and Pandas use some dummy until I materialize them or not? So for Dask, it will use delayed. So we'll have just like let's take one example. You will use your data frame and dot shape. So you will not get the shape. You will get the delayed and ID of this delayed operation until you made compute. So you will not, Dask will not use any dummy. You will output your delayed and the ID of this operation. And after you compute, so you materialize data frame, you can make any operation. One problem here, the problem is if you make some mistake, you will not found them until you materialize. So let's say you have OM, you will not find about them until you materialize. For PySpark, for Spark, as I know, Spark also don't use some data. Data is used as DAG. When you make some operation, transformation, it's just inserting your DAG. And when you do actions, it's now understanding, and now it's make step by step in your DAG. Any question from here? Okay, I can go to the
chat. Yeah.
I can go to the online because I saw a lot of them. Okay, let me see where it's made. And now.
After pluses, I think.
Yeah. Are garbage by comparing single node pandas? So for Pandas, I use term partitions. So the data was split in term partition and we work on at the same time.
Let me read the question because people
Yeah,
will not
so
understand.
are the benchmarks comparing single node data Dask with Pandas, and I use partitioning for Dask, and I set up to 10. And the second, where will be breaking point that makes Dask better than the good old Pandas, when the Pandas could not fit your data frame? So try Dask. If your data frame is more than 100 of gigabytes, then use PySpark or Spark. But another question, is Airflow DAG logic same as Spark DAG? I see no difference in the diagram between a Redis executor, Airflow setup, and Spark. Let me think. Yes, it's no, I don't see the difference between patches Airflow Dask and patch Spark DAGs, or not as that DAG, because they both use for fault tolerant. And if again in Dask in Airflow, if you have some errors, you can use retries and it will execute the same DAG and the same in Spark. So I don't see a difference. How small do we mean the small as an Apache Spark dollar site? So it's not it's not reason to use your PySpark if you have 1 gigabyte or 10 gigabyte. It's better to use when you have pipeline, just use that Spark UI, see how your executors are done, how they are working. If they are not fully, so you might switch to Dask. Okay, and another question. How have you had a chance to try DAGDB for single machine large environment memory use case? No, I had not the chance, but I will read about this tool. And the last question is, how would you go about aggregating a big amount of time series data into multiple time intervals from 15 seconds to 1 hour, 1 day? Okay, so yes, it's a good use case for Spark, but you will have to make partitioning by your time series data. So the data will be split, will have be in the same range. Okay, that's.
Thank you very much. I think that we will end the online part. And if you have any questions in offline part, you can continue and discuss it during the pizza time. So I want to thank you again to all of our speakers, Nata, Alexei, and Mihai. Thank you very much. And thank you everyone for joining offline and online. And have a nice evening. Bye.